looking at completing the square. And the first one, it says solving a quadratic equation using square roots. So before you do anything, we have to know how to solve using square roots, because that's what we want to use after completing the square. So here it says solve x squared plus 30x plus 225 equals 121 using square roots. Uh-oh, that doesn't look like what we did before, right? So remember before we had x squared, or ax squared plus bx equals some number d. And that's, oh sorry, we had ax squared equals some number d. We didn't have a b term. We could have a c term, all right? But here we have a b term. Okay, so if you just look at it, you might think, oh, we can't do square roots here. However, this is a special trinomial. Notice how we have 225. 225, you should notice, is a perfect square. It's 15 squared. Okay, so this is 15 squared, and this is 15 times 2. All right, and because it follows those, we know that this is a perfect square trinomial, so we're going to make it into a perfect square binomial. All right, and we're going to do that by taking our b and divide it by 2. So 30 divided by 2 is 15. Dun dun. And now, that's a positive 15, so we have x plus 15 squared equals 121. And then we want to, the square term is by itself, so we get rid of that square by square rooting. So we square root both sides. But when you square root both sides, remember to put a plus or minus all the time. And here we get x plus 15, the square root and the square cancels out, equals, and then square root of 121 is 11. So we have, we're going to subtract 15 on both sides, and we get x equals negative 15 plus or minus 11. All right. Now we want to do those. So x equals negative 15 plus 11. That's going to give us x equals negative 4. And here, x equals negative 15 minus 11. That's going to give us negative 26. Right? And those are the solutions. Here it says, making a perfect square trinomial, find the value of c that makes x squared plus 40x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So you saw this in class, but we want to make our c into something squared. So if you divide the b by 2, whatever that is, and then square it, that's our c. All right, so what does that mean? First, we're going to label. Label, we have a equals 1, b equals 40, and c, we're not sure yet. So, the way we find c is c equals b divided by 2 squared. So b divided by 2, we have 40 divided by 2. It's going to give us 20 squared equals 400. Ta-da! And now we know that c is 400, so we're going to put x squared plus 40x plus 400. All right, and they want us to write it as a square binomial. And to write it as a square binomial, it's x plus b divided by 2 squared. So whatever our b divided by 2 was, here it's 20. So x plus 20 squared. All right, so keep track of your signs, everybody. And that's that. All right, so let's use that. So solving ax squared plus bx plus c equals 0 when a equals 1. And it's nice when a equals 1, okay? Otherwise, the formula is actually b over 2a. But let's look at this one. Solve this by completing the square. So same thing. We want to find our c. You might think, hey, isn't that 5rc? Actually, no. We want to move that to the other side. So for completing the square, we want the ax squared plus bx equals and some number. Alright, so we get x squared minus 18x equals negative 5. Alright, now here we're going to find our c. So what are we going to add? We're going to do c equals b divided by 2 squared. So our b is negative 18 divided by 2 is negative 9 squared. Ding, 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 ding. Remember this number. So negative 9 squared is 81. So we're going to add 81 to both sides. So here we have x squared minus 18x equals, plus 81 equals negative 5 plus 81. And notice the right side is just adding. So here we have 76. And now this one is, the left side is a perfect square trinomial. That's what completing the square does, right? It allows us to have a perfect square trinomial. So we want to write that as, again, x plus b divided by 2 squared. So what was our b divided by 2? It was not negative 9. So x, not plus this time, minus 9, because it's a negative 9. And there we go. Now I want to square root both sides. So let's square root both sides, put a plus or minus, always. We get x minus 9 equals, and we want to see if we can simplify the square root of 76. Okay. So we want to see if there's a perfect square that goes into 76, and there is, right? 4. So we can write the square root of 76 as the square root of 4 times 19. Where'd that 19 come from? 76 divided by 4 is 19. Alright, so we have the square root of 4 times the square root of 19. The square root of 4 is just 2. The square root of 19 is still a decimal. It's going to be a decimal, so we just leave it like that. Plus or minus 2 times the square root of 19. Alright, and then we add 9 to both sides. And we get x equals 9 plus or minus the square root of, 2 times the square root of 19. Oh, sorry. So this is, well, we could just leave it like that. We don't need to split it up since, oops, there we go. Alright, and here we have solving ax squared plus bx plus c equals 0 when a does not equal 1. Okay, so if it doesn't equal 1, the first thing that you want to do is you want to ask, can something factor out of the coefficients? So we have 2, 20, and 60. And usually we want to try what that lead coefficient is, okay? The first coefficient. So it's 2, and 2 goes into all of those, so let's do it. Divide by 2, divided by 2, divide the right side by 2 as well. And there we get x squared minus 10x plus 30 equals 0. Alright, and then just like before, subtract 30 on both sides, we get x squared minus 10x equals negative 30. And then we're going to do, our b is negative 10 here. So our c is b divided by 2 squared, or negative 10 divided by 2 squared. Negative 10 divided by 2 is negative 5 squared, that's our special number. And negative 5 squared is positive 25. So we're going to add 25 to both sides of this one. So we have x squared minus 10x plus 25 equals negative 30 plus 25. And there we get, this becomes, remember, x plus b divided by 2, so x, and then plus, and b divided by 2 is negative 5, so minus 5 squared equals negative 5. And we're going to square root both sides. Dun dun dun. We have the square root of a negative number, but luckily, we can deal with these now because we have imaginary numbers. So this is going to be x minus 5 equals plus or minus I root 5. Alright, and then we want to add 5 to both sides, and we'll end up with x equals 5 plus or minus I root 5. That's it. Now let's look at writing a quadratic function in vertex form. So we want to write this in vertex form, then identify the vertex. So here sometimes it'll make it a little bit easier if we do change it from standard form to vertex form. Remember, vertex form is y equals a times x minus h squared plus k. So we need to complete the square here. So we're just going to focus on the x squared and the bx. Okay, so we want to just imagine it without that. So we want to do the same thing. Label b, and then do c equals b divided by 2 squared. So our b is 22 divided by 2, 11 squared, which is 21. So we're going to be adding 121. All right. Not just the inside, but also on the outside. Okay, so we added 121, but here we're not supposed to add or subtract any number other than 0. Okay, so it will make adding 121 0, subtracting 121. Right, so there has to be a 1 positive and 1 negative. Doing that, and there we get. Now we want to rewrite this as x plus b divided by 2 squared. So if x plus, and our b divided by 2 was 11. So 11 squared, and then 16 minus 121 is going to give us negative 105. Okay. That's that. Alright, and our vertex is, remember vertex in vertex form is pretty simple because it's always going to be h, comma, k. And if you line this up with this, that h is, it looks like 11, but it's actually negative 11. Remember, you want to think opposite if it's inside the parentheses. So h equals negative 11, and k equals negative 105. So that one is what it looks like. Alright, so that's our vertex. Negative 11, comma, negative 105. And that's that. Alright, now we're going to look at the last one, modeling with mathematics. It says the height y in feet of a baseball t seconds after it's hit can be modeled by the function y equals negative 16t squared plus 80t plus 4. Write the maximum height of the baseball. How long does it take the ball to hit the ground? Alright, so here, this chapter is on completing the square, so we're going to be completing the square. Now actually, we can do this without it. Okay, remember the maximum height. What is the maximum height again? That's their vertex. So we're just looking for the vertex. So you can do b negative b divided by 2a, and that's going to give you the x of the vertex, right? Here, later on it's going to ask how long does it take the ball to hit the ground. Because we don't know the quadratic formula, or we didn't see it yet, we want to use the square roots, or in this case, completing the square. So let's complete the square first. Alright, so y equals negative 16t squared plus 80t plus 4. Alright, so put it in vertex form, just like the previous example. So we're going to put parentheses around here. Just focus on those two. Now here, notice that what goes into 16 and 80? Negative 16. So if you divide those by negative 16, we get t squared, and then minus 16 goes into 800. 800 divided by 16 is 50. T plus 4. Alright, we're almost done. We need to complete the square here. So it's going to be c equals b divided by 2 squared. And our b is negative 50 divided by 2. It's going to give us negative 25 squared, or it's going to give us 625. So what we're going to do is we're going to add 625 to the inside and then subtract it on the outside. So y equals negative 16 times t squared minus 50t plus 625 plus 4, and then here, because we're alright, so here we're not actually adding 625. We're adding 625 times negative 16. So here we're not going to be adding 625 or subtracting 625. We want to do the opposite of 625. 625 times 16. 16 equals, well, perfect, 10,000. Alright, so we did negative 16 times 625 is negative 10,000. Right? But we need the negative of that because here it's positive, so let's make it negative. It's positive 10,000. Okay, and you're probably wondering, why are you adding 10,000? So negative 16 times 625 equals negative 10,000. Here you want to do the opposite of that, so negative 10,000 is positive 10,000. And there we go. Now we're going to write this as a square binomial. So y equals negative 16, and then t, and then our b divided by 2 is negative 25 squared plus 10,004. Ta-da! Oh, oops, I didn't read it correctly. So it says find the maximum vertex, the maximum height of the baseball. So remember the minimum and maximum, that's at the vertex. So we just need to find the vertex. The vertex is, remember h equals not negative 25, but positive 25. Always think opposite if it's inside the parentheses. So positive 25, and k is 10,004. Alright, so because that's our vertex, our y, that's our maximum. And let's put units, so that is in feet. Alright, so that baseball went pretty high, right? 10,004 feet. I'm sorry, I made a mistake here. Must be really tired. Alright, so 80 divided by 16 is not 50. It's 5. Alright, so we're going to change that to 5. Change this to negative 5. And instead of negative 25, it's negative 2.5. And if you're wondering, oh boy, it's a lot of work. Now here, this one, because we squared it, so it moves it not once, but twice. 1, 2. So it's right before, right in between the 6 and the 2. They're adding 6.25. Right, so 6. So it's 50. Alright, so negative 16 times 6.25 is negative 100. That looks better. Alright, so 4 plus 100 is 104, and then we have k is 104. That looks better. Because it's hard to believe that a baseball player can hit it 10,004 feet in the air. So here's just 104 feet in the air. Alright, that's our maximum. Now, how long does it take the ball to hit the ground? Think about it. What is the y when it hits the ground? 0. So we're going to use this formula, the vertex form. Okay, so y equals negative 16 times, oh sorry, this is 2.5, times t minus 2.5 squared plus 104. And we want to let y equal 0, because that's where it touches the ground. Alright, and we have negative 16 times t minus 2.5 squared plus 104. So we're going to subtract 104 from both sides. We get negative 16 times t minus 2.5 squared. Then we want to get rid of that negative 16, so we're going to divide both sides by negative 16. And how many times is, what is 104? Negative 104 divided by 16. That's going to give us 6.5. Equals, and now we have t minus 2.5 Alright. Alright, and I forgot to put that squared here. There you go. Now the opposite of squaring is square rooting. So we square root both sides, plus or minus. And here we have plus or minus the square root of 6.5. Here we have t minus 2.5. The square cancels out. And we add 2.5 to both sides, and we'll get 2.5 plus or minus the square root of 6.5. Now we want to try these, because one of them is going to be correct, one of them is not going to be correct. So plug it into a calculator. 2.5 plus square root of 6.5 and 2.5 minus square root of 6.5.